All right, let's talk about something in the .NET world that can really sneak up on you, a hidden performance trap. We're talking about the big showdown, IEnumerable versus IQueryable. Now, on the surface, they look so similar. They even feel similar when you're writing the code. But what's happening behind the scenes? Well, that can be the difference between an application that flies and one that just grinds to a halt. Okay, so let's set the stage with a really simple scenario. Imagine your database has 1 million customer records, 1 million, and your job is to find just one specific customer. How do you go about it? The way you answer this question is absolutely crucial.
To really get a handle on this, let's use an analogy. Think of your database as this enormous library. Now, you have two basic strategies. Strategy 1, you could march in and tell the person at the front desk, hey, bring me every single book you have, and I'll just find the one I need myself. Or there's strategy 2. You walk up to the expert, the librarian, and you say, can you please find me this one specific book? You can already feel the difference, right?
So let's talk about that first strategy, the one I like to call the downloader. This is the world of IEnumerable. The official definition actually gives us a massive clue here. It represents a forward-only cursor for in-memory collections. And that phrase, in-memory, well, that tells you almost everything you need to know. IEnumerable is built to work with data that's already sitting there in your application's memory. So when you use IEnumerable to talk to a database, the process is simple, but wow, it can be expensive. First, it fetches all the data, every single one of our 1 million customers. It literally downloads the entire library. It's only after all of that is crammed into your app's memory that it finally starts filtering through it all to find that one customer you wanted in the first place. Now, here's the crucial thing. This isn't always a bad approach. This is actually perfect when the data is already in your app's memory, like a simple list or an array. Or maybe the whole data set is just really, really small. I mean, if the library only has 50 books, bringing them all to your desk is no big deal at all. But what if that library is massive? That's when we need our second strategy. So let's meet IQueryable, or as I like to call it, the delegator. The real magic of IQueryable is right here in its definition. See, it doesn't just hold the data, it holds the plan for getting the data. It's smart. It takes your C# code, your filter, and it translates it into a language the database can understand, like SQL. This is our Ask the Librarian approach. First, your code builds a description, an expression of exactly what you want. Then, and this is the key part, it delegates that request to the database. The database does all the heavy lifting, all the searching, all the filtering. And finally, only the results you actually asked for, just that one single customer, gets sent back over the network to your app. So it's probably no surprise that IQueryable is the hero of the story when you're working with a remote database, especially with tools like Entity Framework. When you've got a massive amount of data, you want to delegate the filtering to the system that was literally designed for it, the database itself. All right, enough theory. Let's get to the most important part. What does this actually look like in the code? Because this is where the trap is laid. As you're about to see, the code for both of these approaches looks almost identical. This little table really sums up the whole thing. For the data source, IEnumerable is thinking in memory, while IQueryable is for external things like a database. That means the filtering location for IEnumerable is on your app, the client side. For IQueryable, it's on the database, the server side. And the biggest difference of all, the data transfer. IEnumerable brings everything, all the data. IQueryable, just the filtered results. Okay, now look closely at this code. The key is understanding when stuff happens. That very first line, the one that seems so innocent, that's the line that kicks off the download of all 1 million customers from your database. So by the time you get to the .where clause on the next line, you're not filtering at the database anymore. Nope, you're filtering right inside your app's memory, sifting through a giant mountain of data it just downloaded. Now let's contrast that with the IQueryable version. That first line, it does almost nothing. It's just building a plan. It's the combination of the .where and that final .to list that actually pulls the trigger. The whole expression gets translated into one super efficient SQL query with a where clause. It's sent to the database, and only the customers from Pune are ever returned. No massive, unnecessary data download. So, now that we've seen what's really happening behind the scenes, how do you make the right choice when you're writing your own code? Well, it really all comes down to asking yourself one simple question. Where is my data, and where should the filtering happen? Here's your cheat sheet, plain and simple.
Use IEnumerable when your data is already local, right there in memory, like a list or an array. It's perfect for that. Or if the whole collection is tiny and performance isn't even a thought. But if you are querying a database, especially with large tables, you should almost always be using IQueryable. Let the database do what it does best, filter huge amounts of data with incredible efficiency.
So here's the thought I want to leave you with. It is so easy to write code that works, but is secretly horribly inefficient. So the next time you write a query, just stop and ask yourself, am I about to download the entire library, or am I just going to ask the librarian for what I actually need? Because that answer could have a massive impact on how well your application